Hi guys. We're continuing with our section 6-2, which is solving using substitution. Today, our problems will not be set up for substitution, so we'll need to do a pre-step of work to get it in the right format. Here is our first example. Now, yesterday we talked about how when you're solving by substitution, one of your equations needs to have a variable completely by itself. In this problem, none of my letters are alone. They all have other numbers, other letters, symbols with them. So as a pre-step, before I actually start doing substitution, I will need to isolate one of my variables, get a variable all by itself. Now, in reality, it does not matter which variable you choose to get alone, but there is an easiest variable to get by itself. So what you want to look for is you want to look for a variable that does not have a coefficient. That means there's not a number in front of it. And best case scenario would be a variable that is positive right now. Those are the easiest letters to get by themselves. So in this problem, I will not be getting my letter x by itself because both of my x's have a number in front of them. And if I'm going to choose between my two-letter y's, I'm going to choose the y from the first equation since it is positive. So as a pre-step, I'm going to get this letter y to be all by itself on the left side of this problem. Having chosen that letter y to get by itself, I only need to do one step of work. All I have to do is subtract the 2x to the other side, and my y is alone. So by choosing a letter that does not have a coefficient and that is positive, I can get it all by itself with just that one step. Now that I have a variable that's all alone, I'm ready for substitution. Now you have to be a little bit careful on this problem. So you want to make sure that when you're substituting the equation that you solved for into the second equation, the one that you did not solve for. So we don't want to accidentally substitute this equation back into itself. So we want to make sure that we are using the second equation. So I'm going to replace this y down here with the 7 minus 2x. Now, whenever you're substituting, it's important to take what you're plugging in and surround it in some parentheses. Even if there wasn't a number in front of your variable, particularly in this problem, there's a minus sign. So we will have to distribute. We're going to be distributing that minus sign. So again, make sure to put it in parentheses so that you remember to distribute. And that's what I'm going to do next, right? So I'm going to distribute my negative, and I get this. In my personal opinion, the next step I like to combine like terms. So I'm going to add my 3x and my 2x. I'll add 7. This is all stuff from our chapter 2, so I'm going a little bit quickly. And then as a final step, I'll divide both sides by the 5. And I get x equals 3. Now, don't forget, we're only halfway through with this problem. X equals 3 is half of my ordered pair, but I do need an ordered pair, so I need my x number and my y number. So I will now be taking my x number, and I'm going to substitute it back into one of the top equations. The only requirement is it's got to be substituted into an equation that has 2 letters in it, an x and a y. In this problem, I actually have 3 options, right? I have my original 2 equations, and I have this new equation that I created. So you can use whichever one you want. It doesn't matter. You'll get the same answer for any of them. Again, my personal preference, because I think it's the easiest mathematically to calculate, is to plug it into the one that has the y all by itself. So I'll be plugging my 3 into this equation. 2 times 3 is 6, and 7 minus 6 is 1. And I now have both of my numbers, so I can write my one solution, which is the ordered pair 3, 1. Remember, this is considered to be one solution because it is a single dot on the graph. Let's try another one. So in this problem, again, none of my variables are by themselves. Every variable has other stuff on the same side of the equation. So I will need to do that pre-step and get a variable alone. Now you can pick any letter you want, but there is a letter that will make your life a little bit easier. In this particular problem, that letter is the letter X from the first equation. Again, I'm choosing the letter X from the first equation to get by itself because it does not have a coefficient and it's positive. Every other letter has a number in front of it. If you solve for a letter that has a number in front of it, you're going to have to divide and it's going to create fractions and it's just not going to be fun. So pick a letter that does not have a number in front of it. That way you do one step. In this problem, I'm going to minus my 2y, and now my X is all by itself. Now that my X is by itself, I can substitute. Don't forget, we're substituting it into the equation that I have not used yet. In this problem, that would be the second equation. So I'm going to take the 4 minus 2y, and I'm going to substitute it for the X in the second equation. When I plug it in, I'm going to surround it with parentheses. And then notice that everything else in the equation is still there. So some common mistakes that I see students make is they'll forget to write the minus 2y because they already wrote it here as part of their substitution. But you do need to write everything that stayed in the black typing. The only thing that's not going to show up in your new equation is this red letter X. So really make sure that you're writing the rest of the problem out. All right, I'm now ready to distribute. I'm going to combine like terms. I'm going to minus my 12 to the other side. And I'm going to finish up by dividing by the -8. And I get my first number, but not my whole answer. It's only half the answer. My first number is y equals 1. After you get your first number, make sure to plug it back in to get your second number. You can plug it into, again, any of the top 3 equations. As long as your equation has an x and a y in it, it's fair game. And then just make sure that you're plugging it into the right letter. So that's another common mistake that I see students make is they'll plug this in, instead of plugging it into the y, they might accidentally plug it into the x instead. And so just be very aware of which letter you're working with. I'm going to plug it into my new equation, the one that says x equals, and do a little mental math. 2 times 1 is 2, and 4 minus 2 is 2. Remember, your ordered pair needs to be in alphabetical order. So even though I found my x number second, it goes first in the ordered pair because that's how ordered pairs work. They go x, comma, y. My final answer for this question is 2, comma, 1. Let's do one more together for our notes, and then you can go work on your homework. Again, in this problem, it is not set up for substitution right now, so I will need to do a little bit of manipulation to make it work for a substitution. I'm going to choose the only letter that does not have a number in front of it, which is this first letter X. And I'm going to get that by itself by subtracting the 2y to the other side. Now that the X is alone, I can substitute 4 minus 2y into my X in my other equation. Remember, don't accidentally substitute it back into itself. Make sure you're using the second equation. Here, I'm going to distribute. And I'm going to combine like terms. Now, this one is a special case, and we had an example of a special case yesterday as well. So I know this one is going to be a special case because I have a -7y and a +7y, and those are going to make 0 letter y's. So those are going to cancel out my y's completely, leaving me with just the numbers 14 equals 14. If all of your variables cancel and you get 2 numbers, then you need to ask yourself, is this true? Does 14 equal 14? And yes, it is true. 14 does equal 14. Now, yesterday we said when it is not true, you write no solution. There are no answers to this problem. If I were to graph it, the lines would not intersect. Today, though, we got that this problem is true. 14 does equal 14. So we need to use our other special answer from this chapter. The other special answer from this chapter is the phrase infinitely many. Remember, we are not saying all real numbers in this chapter because that implies that the entire graph is an answer, when in reality, it's just the line that is the answer. So infinitely many because the line is infinitely long. This problem, if I were to graph it, would be that problem where both equations are the same. You would graph your first line and then your second line would be like right on top of your first line. So that's what this would look like graphically. But today we're doing substitution. So this is what it looks like when solving using substitution. This concludes our notes about substitution.